In the previous tutorial video, you have learned how to find, load, and play the sounds and virtual instruments from the Absinthe preset library. But you can also create your own sounds from scratch. Understanding these next basic principles of audio synthesis will allow you to not only understand how each preset is built, but it will also allow you to manipulate and adjust each preset according to your own will, or in a more advanced stage, to build the desired sound from scratch. The patch window is used for creating the foundation for any sound within the semi-modular design of Absinthe 5. In this video, you will understand the role of every single component within your sound generator, modulator, or processor, thus allowing you to obtain and to shape your sound very precisely. First, let's start by creating a new sound. On the File menu, select New Sound to create a new empty sound. You can also set up a new sound by pressing the key combination Ctrl-N on Windows system or Command-N on a Mac system. The basic element that generates sound is called oscillator. At least one oscillator must be active for Absinthe 5 to produce an audio signal. As you can see, when you select the New Sound option from the File drop-down menu, an oscillator module will automatically be created in channel A with its waveform set to sine. You should be able to play this oscillator by pressing keys from your MIDI keyboard or from the virtual keyboard itself. This will generate a sound corresponding to the frequency of the note being played. Absinthe 5 allows you to combine up to 3 individual oscillators, A, B, and C, one per each channel. These framed areas are called module slots. You can combine up to 3 oscillators, filters, and effects, one for each channel, before merging the signal flow from each channel into one single master signal. This merged master signal can also be shaped or processed through a filter or an effect. To activate or deactivate any of these module slots, you must simply press it once on the highlighted label area. Note that you must first have an oscillator activated in order to apply any filter or modulator effect over that same channel. If you remove the oscillator generating a sound on a certain channel, the filter and modulator options on that same channel will also be deactivated, as there is no longer any sound running through that channel. The remaining control options on the patch window are related to volume and panoramic. The yellow horizontal bar displayed at the bottom of each channel works just like a normal volume fader. This allows you to control the volume being sent per channel to the master output channel. You can also specify how far out you would like the sound coming from each channel to be heard in a 300-degree surround area by pressing this button on the master channel. This will open a panoramic option for each activated strip A, B, and C. You can now indicate whether you would like the sound to be heard coming from the left, right, front, or back. Let's now try to understand a little more about oscillators. This first drop-down menu lets you choose the signal type from 3 groups of synthesis modes, from single to sync granular. You have these 6 wave levels of oscillator types. These generate signals based on monocycled waveforms. The next group presents 2 different sampling sources. When selecting any of these, the oscillator will generate sound depending on the sample sources. The third and last group delivers an audio signal that comes from the external audio in input source. This allows you to use a signal coming from a microphone or instrument and running it through Absinthe. In order to make things simple at this stage, let's keep the single signal type. The second drop-down menu allows you to choose between wave types. At this moment, it is set to sine, which is the most basic wave type there is. Let's have a listen while I shift from different wave types. Also, notice that a graphic preview of each wave is given when shifting between wave types. Each wave type will display a different waveform appearance depending on the complexity of the harmonic frequencies of each wave type. The best way for you to get to know each wave type is by testing them out. You also get to select between morph and library waves. Morph waves are basically two simple waveforms blend together. I'll later on explain to you the complexity of mixing two simple waveforms into one morph wave, depending on its phase and harmonic frequencies. But let's now listen to a couple of examples from the list. As for library waves, they're basically waveform presets provided by Absinthe. The top left switch on every oscillator is the anti-alias switch. This option allows you to smooth peaks in various situations, particularly in the higher frequencies, providing you with a smooth, almost analog type of sound. When the symbol displays little steps, the anti-aliasing function is off. The smooth line indicates that this function is now on for this oscillator. Next, there is the frequency control, which is made of this drop-down menu of frequency module, a numeric field, and these three value sliders. You can select for it to change its frequency transposing it by semitones, frequency ratio, or setting a specific value in Hertz or MIDI note. Let's set it to Hertz so I can demonstrate to you the basics of pitch shifting. The three value sliders that follow the numeric field change the value selected by smaller amounts from left to right. Note that you can also enter a specific amount by clicking over it with your mouse and typing it down on your keyboard numeric pad. Once a value in Hertz is entered, every key on your MIDI controller will play the same sound at the chosen frequency. This can be useful, for instance, if your intention is to play a chord or a combination of three different pitches by pressing one single note. To better understand this concept, let's activate the three independent oscillators and set them to transpose mode. Next, let's set each transpose level to a different value so that the same note plays at three different octaves. My main goal by showing you this feature is that you understand how to combine different oscillators to generate different sounds, mixing them to produce one combined audio result. Remember that for each oscillator, you can set a different pitch value and wave type in order to obtain a more complex and interesting audio texture. The single waveform has one more menu available, the Uni menu. This allows you to set multi-voicing to an oscillator level. Basically, this means that you can set up to 8 versions of the same wave playing in sync. This is basically what we were doing a moment ago with the three oscillators all together. So if we change the transpose value, we will achieve a full sound, since we are basically listening to a group of different frequencies spread out over the number of voices chosen. Another way to add more texture to the sound created is to add random frequencies with a random slider underneath. It produces a detuning of the voices with the notes set within their frequency range. Now, let's move on to filters. At this point, I want to show you how to filter the merge master output. Start by turning on the filter in the master slot. Filters are basically used to process sound coming from a source, such as oscillators or any other audio input. I could be more specific and add an independent filter for each oscillator. But right now, I really want you to listen and understand how it works as a general idea with the results we have so far. The signals coming from all three oscillators are combined in the master channel and run through the filter. For this next step, we will be using a low-pass filter with a frequency slope that cuts frequencies above 1000 Hz. To do this, click on the filter type and choose LPF2 pole. Below, set the frequency to 1000 using the sliders or typing it directly into your number display. Notice that the sound being produced is now less aggressive in the high frequencies, keeping that low, warm feeling to it. The resonance setting underneath the frequency value gives your sound a little more presence. To test it, I'll set it to a low value like 0.3. At the bottom, there is a damping control option. This will let you compensate the outcoming filter result for the attenuation being caused by the filter. Absinthe 5 introduces a very interesting and unusual feature, the feedback loop. This allows you to send a portion of the filter's output back to its own input, processing the outcome all over again. This option is available for most of the filter types, but not for all of them. If you notice closely, the filter feedback is now set to normal, which means that the filter feedback loop is actually turned off. There are three different types of options: wave shape, frequency shift, and ring modulation. When chosen, the feedback panel displays the settings for that particular feedback mode. Like in every other feature available on Absinthe, I suggest that you play around with every setting and option. This will allow you to achieve very interesting results. The applications to the feedback loops are endless, but they will mostly depend on the audio material sent to the filter. I happen to use this option a lot when receiving audio from an external sound source. My suggestion is that you play around a little more with different filters and options. The best way to test these results is always pushing them to a limit. You can also check the different filters applied to the 1400 presets provided by Absinthe 5. Remember that these filters can be applied to single channels or to the master channel. We will return to the patch menu on our next video, modulation and waveforms.